Okay, now we're back in part 2 of the video. So we just finished number 4. Let's go to number 5. 5 is going to be pretty much like the last one. We know 2 of the sides of the triangle. We don't know the hypotenuse, which is c. So we're going to do Pythagorean Theorem. Got 2 squared plus 4 squared equals c squared. 2 squared is 4. 4 squared is 16. You're going to get c squared equals 20. And then you're going to square root it. When you square root it, you're going to do exact answers only, which means no decimals. So you got to do a little factor tree. Perfect square that goes into 20 is 4, 5 times. Square root of 4 is 2, and we have a leftover 5. So that missing side is 2 root 5. Once we know that, then we can find the sine, cosine, and tangent of all these angles. First one we're going to do is angle G. So if we're looking at angle G, this side that we just found to be 2 root 5 is the hypotenuse. So this is my hypotenuse. The side that does not touch angle G, which is 2, that's my opposite side. And then 4, which is right next to it, is my adjacent side. So when I do the sine of angle G, I have opposite 2 over the hypotenuse, 2 root 5. 2 over 2 root 5. And we've been doing a bunch with square roots already. You can't leave a square root in the denominator. So we're going to rationalize by multiplying the top and bottom by square root of 5. So on the top you get 2 root 5. On the bottom, square root of 5 times square root of 5 is 5. Times that by 2, you get 10. And then reduce the 2 over 10. That's going to give you 1 over 5. So you can leave the 1 there or you don't have to. It's the same thing as saying root 5 over 5. So that's my sine. Cosine is going to be adjacent over hypotenuse. 4 over 2 root 5. Now this one, you can simplify it a little bit and get rid of the radical. 4 divided by 2, that's the same thing as saying 2 over 1. So I just reduced 4 over 2, and then I can get rid of the root 5 by rationalizing it. So when I rationalize it, I get 2 root 5 on top and 5 on the bottom, because root 5 times root 5 is 5. So I have 2 root 5 over 5. Tangent is opposite over adjacent. That one's nice and easy. 2 over 4, you reduce, you get 1/2. No dealing with radicals for that one. Now we're going to deal with angle H. So we're going to erase angle G, and my hypotenuse is going to stay the same. My opposite is going to be erased. So I'm going to circle angle H. The opposite side is across from it. Adjacent is next to it. The sine of angle H would be opposite over hypotenuse. So 4 over 2 root 5. And we already did that with the cosine up here. We did 4 over 2 root 5, and we already simplified it. So we already know what it simplifies to be. We don't have to do it again. It's 2 root 5 over 5. Now we got cosine of angle H. Cosine is adjacent over hypotenuse. 2 over 2 root 5. Again, we already did that up here. We had 2 over 2 root 5. We simplified it already. It was root 5 over 5. So it saves us some time. We don't have to rationalize again because we already did it. And then tangent is going to be opposite over adjacent, 4 over 2, which reduces to just be 2. So that's how you do those. Question, it says, what do you notice about the sine and cosine of the acute angles? So if you notice, these guys were pretty much the same thing. The sine up here was the cosine down here. The cosine up with angle G was the sine for angle H. So they're pretty much the same, except they're switched. So that's what we're going to write. When you change the reference angle, so going between like G and H, when you change the reference angle, the sine and cosine switch. And that's because the opposite and adjacent sides are switching. Because the opposite and adjacent sides switch. What is the relationship between the two acute angles? Well, obviously angle I is 90. And we know that there's 180 degrees in a triangle. So if there's 180 degrees in a triangle and I is already 90, that leaves us with 90 degrees for those two angles. So we're left with 90 degrees for angle G and angle H. 90 degrees, they add up to 90. If you remember a long time ago, if they add up to 90, that means they are complementary. So these two angles, angle G and angle H, or the two acute angles, are complementary. The two acute angles are complementary. Again, they add up to 90 degrees. And hopefully that makes sense, because 90 plus another 90 would give us 180. And that's going to come in handy down here where it says the big idea. So we know that if we gave this triangle some sides, x, y, and z, let's say, if we find the sine of whatever a is, we know that's going to be the opposite over the hypotenuse. Opposite side from angle A would be x, and the hypotenuse would be z. And we know that if we do the cosine of the other angle, in this case B, it should be the same thing, because that's what we just talked about up there. Cosine of this angle will be adjacent over hypotenuse. Adjacent would be x, and hypotenuse is z. And so if you notice, they are the same thing. So because they equal the same thing, we know that the sine of angle A has to equal the cosine of angle B. We know that. And what we also know is that these two angles have to add up to 90. So if we know that the sine of the one angle equals the cosine of the other angle, we know that A plus B has to add up to equal 90. And we're going to use that on these problems down here. So if you look at these problems down here, we got the sine of one angle equals the cosine of the other angle. If you have this situation, we know that those two angles, whatever they are in the parentheses, add up to equal 90. They're complementary. So in this problem, 3x plus 6x is going to equal 90. And then you solve for x. So you get 9x equals 90. X is going to be 10. Same with number 7. Because the cosine of something equals the sine of something, we know that these two have to add up to be 90. So we got 5x plus 20 plus 7x minus 2 has to equal 90. You get 12x plus 18 equals 90. Subtract the 18, you get 12x equals 72. Divide, you get 6. So it's just basic solving for x. You just need to know they add up to 90. Same thing here. Cosine of some angle equals the sine of the other angle. They have to be complementary. So if I add those two up, it should equal 90. 4 and 5 makes 9x. Negative 1 and negative 8 makes negative 9. Add the 9, you get 99. Divide, you get 11. And then 9 is the same thing. Cosine of something equals the sine of something. Those two things add up to 90. So 6x plus 2 plus 16x equals 90. You get 22x plus 2 equals 90. Subtract the 2, you get 22x equals 88. So x is going to be 4. Alright, so last page. Given the ratio and an angle, determine which trig function is represented. So we're going to be writing sine, cos, or tangent. Again, remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we got 20 over 29, and we're talking about angle R. So here's angle R. 20 is across from angle R. That's the opposite side to angle R. And then 29 is the hypotenuse. So we're given opposite on top and hypotenuse on the bottom. Opposite over hypotenuse is going to be sine. So that's what you're going to write here, sine. Then we've got angle A. So I'm going to erase all of this stuff. Angle A is here, and we're given 21 over 20. Well, 21 is across from angle A. That's opposite. And then 20 is adjacent. It's next to angle A. It's not the hypotenuse, it's adjacent. So we've got opposite over adjacent. We look over here, opposite over adjacent is tangent. So we put tan on the line. And then the last one we have is angle A once again. We've got 20, which again is the adjacent side, over 29, and 29 is the hypotenuse. So we've got adjacent over hypotenuse. Adjacent over hypotenuse is cosine. And then we got this guy. Determine which trig function is represented. Same as kind of the one above. We've got angle N. We've got 24 over 25. 24 is the adjacent side. 25 is the hypotenuse. So we're looking at adjacent over hypotenuse. That's going to be cosine. Then we've got angle U. I'm going to leave the hypotenuse up there. Well, yeah, I'll erase it. Angle U, 24 over 25. 24 is across from angle U, so that's the opposite side. 25 is the hypotenuse. So we've got opposite over hypotenuse. If we look at our ratios up here, opposite over hypotenuse is sine. So we'll write sine on the line. And then we have angle U once again, and we are talking about 24 over 7. We know that 24 is the opposite. 7 is going to be the adjacent side. So we're talking about opposite over adjacent. That would be tangent. All right, and then we've got these two problems and then we're done. I know these are long notes. So for this one, you've got the cosine of angle P is 12 over 37. Find the sine of P. What you're going to want to do is draw a picture. All right, we're talking about the cosine of angle P. So I'm going to put P right here. And then you can put the I and the G really anywhere. It doesn't matter. Just put the P kind of on the bottom as one of the acute angles. Cosine is 12 over 37. Cosine is adjacent over hypotenuse. So the adjacent side would be here, and the hypotenuse would be here. Adjacent is 12. The hypotenuse is 37. And once you have it kind of drawn, now we got to find the sine. The sine we know is opposite over hypotenuse. I know the hypotenuse. I don't know what the opposite side is. The opposite side is this guy. So what you're going to have to do is draw the picture like we did and now find out what this opposite side is by doing Pythagorean Theorem. So we're going to do x squared plus 12 squared equals 37 squared. To save a little bit of time, I think most of you are familiar with the Pythagorean Theorem, you're going to end up getting x equals 35. All right? So this missing piece here is 35. Once you know that, opposite over hypotenuse is easy. Opposite, 35, over hypotenuse, 37. And that's your answer. So the sine of P is 35 over 37. And then same for the problem right below. You've got tug, so T can go down here, or no, we're talking about angle G. So angle G is going to go down here, and then T and U can go really anywhere. Angle G, we got tangent. Tangent is opposite over adjacent. Opposite is here, adjacent is here. Opposite is 3, adjacent is 4. Now we need to find the sine. Sine is opposite over hypotenuse. We don't know what the hypotenuse is. So again, you're going to do what we did in the last one. We're going to have to do Pythagorean Theorem. We're going to have to do 3 squared plus 4 squared equals x squared. If you do that, you will get x equals 5. So this missing piece is 5. And then you can easily do the sine of that angle. So sine of G would be opposite 3 over hypotenuse 5. So the sine of G is 3 over 5. All right, I'm sorry for the long notes, but hopefully they're not too bad. Good luck, and you have the homework. It's on the homework guide. Good luck. Thanks.